where does the major scale come from? Why are those notes in that order and that with that spacing? If you look at a major scale on a piano, let's play it in C, C, D, E, F, G, A, B, C, you'll notice that some notes have black keys in between and some don't. So they're spaced differently. Why is that? Where do these notes come from? The short answer is, as we talked about earlier, when you play any note, there's the fundamental and then there are overtones. And eventually, if you stack up all of these overlapping waves of C, for instance, you will get all these other notes. The next one that will show up is a G, an E flat, but you'll get all these other notes in the overtones. But constructing the scale was really a matter of balance between practicality and harmony. So take a string and pluck it, stretch it tight and pluck it, you get a note. That's our root note, our fundamental. If you make a string half as long and pluck it, half the length equals double the frequency. So that becomes an octave. So if your first string was a C, your second string is a C an octave higher. Now, if you take a third of the string, the third of that string to a half of a string, that is a ratio of 3 to 2, that gives you that, in our key of C, that G note, the fifth of the scale. If you take a fourth of the string to a third of the string, a 4 to 3 ratio, you get the fourth of the scale, F. And a fifth of the string to the fourth of the string, we're just going up 2 to 1, 3 to 2, 4 to 3, 5 to 4. At 5 to 4, we get a major third, which I'll describe in a moment. And at 6 to 5, we get a minor third. And they're all whole number ratios which tend to make harmonious frequencies. So just those first ratios using the numbers 1 through 5, we get in the key of C, we get C, E, F, G, and C again. That leaves a gap between C and E, and it leaves a fairly big gap between that G, the fifth, that is a ratio of 3 to 2, and then the octave. But if we look for some more whole number ratios, so the ratios of the 1, 3, and 5, which in the key of C would be C, E, and G, that's a 4, 5, 6 ratio. If we do the same thing with the key of G, and with the note, the G note, a 4, 5, 6 ratio gives the notes G, B, and D. And a B happens to be approximately 15 to 8, which is a whole number ratio. And a D is approximately 9 to 8. And then if we do the same thing with the fourth note, that F, 4, 5, 6 ratio is FAC. So then the A is a 5 to 3 ratio. So this evolved over time. It started off with the Pythagorean tuning, this concept of split a string up into equal portions and then compare the ratios of those bits of string. But over time, we ended up with an 8-note scale that was made up of a bunch of fairly even proportions, fairly evenly spaced, using whole numbers. And then using slightly different proportions, we can get the minor scale. And in fact, the minor scale is just the major scale starting at a different spot. The C major scale uses all the white notes on the piano. The A minor scale just starts on A instead of C. So they're the same notes, just as you go through the proportions, they're different. You may have remembered a scale on the piano as the number of gaps, whole, whole, half, whole, 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 half. That shows you where to skip the black notes in the key of C. And a minor scale just has the wholes and halves in different places. And that's what gives the scale its sound. But the way these notes came together is just, it evolved over time, starting from some basic tones that worked together well, and then in a search for instance, if you're going to build a little harp, you want more than just those first 5 notes if you can, and you start adding other notes, looking for measurements that are easy to measure, but also harmonious. Now, the issue with that, all that stuff, is that if you made a little harp with 1 octave of notes on it, then you're okay. But to take those strict proportions, whole number proportions, and expand it to a piano keyboard, the math breaks down. And again, knowing why and how will not help your music theory, so we're not going to go into that. But over time, in order to be able to tune a piano or a guitar and be able to play in every key instead of just 1 key, eventually this scale of 12 notes, using all of these proportions, was split up into 12 equal spaces. So originally, the Pythagorean tuning of these proportions came to be called just intonation, just as in fair. But this new proportion where they're all equal is equal temperament. The notes on your piano, most of them are just slightly out of tune, but slightly enough that you can't really hear it. But the origins of the scales, the major scale and the minor scale, comes down to proportions, basically, splitting a string up into different equal portions and then comparing those ratios to each other. This is Joel D. Canfield.